terms of the system that's actually there at the moment, testing is done on an individual basis between the tester and the client, and none of that is actually shared either across industry or to other clients, which means it's an opportunity miss. What Cladding Safety Victoria has been able to do is to do the testing, universally share it and make sure that it is actually available on our website.
So at the moment we're doing some pre-test checks. So what we have in front of us, you can see the white portions up either shoulder. That's the ACP that we're investigating. There's a lot of dotting I's and crossing T's before anything really kicks off. As you'll see from the actual test, there's no mulligans. We can't take anything back once we actually start the fire. So making sure that designs are representative, substitutions of materials if we can't get access to them, and baseline instrumentation requirements, just to make sure we capture as much as we can from a single burn.
It's not a simple case of walking up and flicking a match onto some particular material. The tip of the iceberg is the burning itself. Before any test, there is months of work.
A lot of the outcomes, they are what they are. So being able to provide certainty with an outcome rather than an estimate or an opinion always allows us to sleep a little bit more soundly at night.
So we were really lucky to actually have Professor Kate Newen come and join our team. She is obviously a world recognised materials expert.
I'm a professor at RMIT University. I also lead the Innovative Fire and Facade Engineering Research Group over there. My background is kind of interdisciplinary between materials, chemicals, civil and fire safety engineering. It has been a really great honor for me and my research group at RMIT to be involved in CSV's program.
The other significant part that we've been able to go and myth bust effectively is the ACP FR, which is the flame retardant.
The composition of the cladding, it is quite important, the ratio between the polymer and the flame retardant, the actual flame retardant, not the filler. That is the first important key finding. And the second thing that we found was that when you have different types of cladding, they have very different mechanism of fire spread, and that is both vertically and horizontally.
And so if you've got a 1-to-1 ratio greater on the active materials, or the active minerals rather, the rate of fire spread, indeed the fire spread going in the vertical part, is significantly reduced, such that we can actually say with very, very strong confidence that this stuff, whilst it's combustible, it's slow and it's far more tolerable in terms of its usage.
Having some sort of a testing database at this scale, I think it is really important for, for science, for research and for the industry in general.